Alright, so today is day 2 of classifying polynomials. On Friday, we classified based on the degree and the number of terms. And then today we're going to be classifying the end behavior and turning points of these polynomials. So just as a refresher, remember that the degree is given by the term with the highest degree. So the highest exponent overall becomes my degree. And then the terms must be in standard form. So they need to be in order. And then the number of terms must be combined first. So in order to get our number of terms overall, we need to make sure that we combine any of the like terms first. So what is the classification of the following polynomial by its degree and number of terms? So we see that we have some terms that would need to combine. My highest degree is a 6, and so 4x to the 6 minus x to the 6 is 3x to the 6. And we're looking for a fifth power. I don't see one. Then a fourth power. I have this one and this one. So 5 plus 3 gives me 8x to the fourth. Then we're looking for a third power. That is the only one, so plus 9x to the third. Then we're looking for a square. We don't have one. Go to x's. There's only one. And then the constant minus 12. So we need to find the degree and number of terms. The degree is 6. And we have 1, 2, 3, 4, 5 terms. So that means this is a hexic polynomial. So this goes through the steps. First, we need to combine our like terms, place them in descending order, and then we look at the degree and the number of terms. So then this is what is new today. Step 4 is determining the end behavior of the polynomial. So it's going to tell me if it's going to be pointing up, pointing down, on the left, and on the right. And we get that based on the degree of the polynomial. So if A, which is the leading term's coefficient, and then the degree of the polynomial, we're going to call n. So the end behavior is determined by the degree of the polynomial and the lead coefficient. So if a, the lead coefficient, is positive and n is even, the end behavior is up and up. If a is positive and n is odd, the end behavior is down then up. If a is negative and n is even, the end behavior is down and down. And if a is negative and n is odd, the end behavior is up and down. So I imagine that upon hearing that, you have no idea what just happened. So if a is positive and n is even, then our graph is going to go up, up. Those are terrible arrows, I'm sorry. If a is positive and n is odd, then we're going to go down, then up. If a is negative and n is even, then my graph will be down, down. If a is negative and my graph is odd, then our end behavior will be up, then down. So what do we notice? Whenever it is even, the two arrows are facing in the same direction. So an even graph is going to be up, up, or down, down. And that's the degree. So if the degree is even, we're going to have matching arrows. And then the last arrow is determined by positive or negative for odd graphs. So if you have an odd graph, if the coefficient is positive, your last arrow will be up, but you will have opposites. And then if A is negative, your last arrow will be down and you will have opposites as well. So the more examples we do, the more this is going to make sense. And so with the problem that we did, we had 3x to the 6. And so A is the lead coefficient, so that would be 3, and it's positive. N is the degree, which is 6, and it's even. Even means they'll be the same. And positive tells me they'll be both up. So then I have up and up. So we're going to do a couple examples so that way we can see how this works. So first we want to check, can I combine any of my terms? On example 1, I can't. But I know they're not in order, so I'm going to rewrite it in order with the highest degree first. So I have 4x cubed plus 2x minus 1. The degree is the highest exponent, so that's 3. The leading coefficient is 4. 3 is odd. And 4 is positive. So positive tells me my last arrow is going to be up. And then the 3 being odd tells me that they're going to be opposites. Number of terms is 3. We're not going to talk about the number of terms per se. And so we will classify it based on degree and the number of terms. So we have a degree of 3, which means it is a cubic. And we have 3 terms, which means it is a trinomial. Then on practice 1, we have 7x cubed minus 11x plus x to the 5th power minus 2. So I'm going to combine any like terms if I can. I don't see any that I can combine, so I'll just jump straight into writing it in standard form. X to the 5th is first plus 7x to the 3rd minus 11x minus 2. The degree is the highest exponent. That 5 is odd. The leading coefficient is a 1, since I don't see a number here in front of x, and that is positive. Number of terms is 4, and the end behavior we get from the degree and the leading coefficient. So since the last one I get from positive or negative, I know that's going to be facing up, and it is odd, so they will be opposites, so I have down, up. We're going to skip over terms, and then we'll classify it based on the number of terms and the degree. Degree of 5 is quintic, and the number of terms, 4, is just a polynomial. Now in example 2, we have this very large problem here, and so we are going to combine any like terms if we can and make sure that we write it in standard form. So I see 5 is my highest. I have 7x to the 5th plus x to the 5th, which gives me 8x to the 5th. Then I would look for a 4. I only see 1, so plus x to the 4th. I'm going to cross them out as I go. Next would be a 3. Then a 2, I don't see one. Then a degree of 1, which would just be my plain x's. I have 3x minus x, so that's plus 2x. And then the constant, which is plus 1. Degree is the highest exponent, it's 5, which is odd. The leading coefficient is 8, which is which is positive. Positive tells me my end behavior will end on up. Odd tells me they'll be opposites. Number of terms, 1, 2, 3, 4, 5. So when I'm classifying, it has a degree of 5, so it is quintic, and it has 5 terms, so that's a polynomial. On practice 2, we're going to combine our like terms again, and I see that 4 is my highest degree, so 2x to the 4th plus x to the 4th gives me 3x to the 4th. Then a degree of 3 would be next. 4x to the 3rd plus x to the 3rd is 5x to the 3rd. And a degree of 2, 7x squared. Degree of 1 minus x, and a constant, which is plus 1. Degree is 4, which is even. Leading coefficient is 3, which is positive. Positive tells me the last one's up. Even tells me they'll be the same. Number of terms, I have 1, 2, 3, 4, 5 terms. When we classify, we go by degree and number of terms. So it has a degree of 4, which is quartic. And the number of terms is 5, so that's a polynomial. Now when we're looking at the graphs, we will look at the end behaviors. To get what our degrees and our leading coefficients are. So the number of zeros, we see that there's 1, 2, 3 zeros. And since we have opposite arrows, our degree would be odd. And our leading coefficient would have to be negative, since that last arrow is pointing down. Now on the next graph, we'll do the same thing. My end behavior is down, up. So that tells me that the degree has to be odd, and the leading coefficient would have to be positive, since that last arrow is facing up, and the number of zeros we'll take from the graph, 1, 2, and 3. So then for your homework, this first section says write each polynomial in standard form, then classify it by degree and number of terms. So this is like what we did on Friday. Then the next section is determine the end behavior. So this is what we did today. This is like that last part of the notes. And then we're not going to go through this last section because it's exactly the same as the first, classifying by degree and number of terms. So I'm only going to give you a 1 through 17 to do, and both of these are like today.